Welcome to the Deep Dive. We cut through the noise to get you the insights that matter. Today we're talking about something really crucial in medicine, systematic literature reviews, SLRs. Now these aren't just, dusty academic papers. They're considered the highest level of evidence. They genuinely shape clinical practice, research direction, healthcare policy, basically the care you get. But, and this is a big but, doing them traditionally, it's incredibly slow, like 6 to 16 months slow, sometimes even up to 2 years. And the workload is immense. Just think, for the abstract screening part alone, maybe 85% of the papers get tossed out. It's like manually panning for gold.
Yeah, it's a huge amount of manual effort. And that process, well, it's tiring, it leads to errors, maybe even some bias creeping in.
Exactly. So what if there was a better way? That's what we're digging into today. We're looking at a really interesting paper from Ying Li and colleagues, just out in 2025. They developed and tested an AI-assisted system for SLRs, and it's particularly focused on health technology assessments, HTAs, which are super important for deciding which treatments get used. So our mission today, show you how AI, specifically GPT-4 in this case, is tackling this massive bottleneck, how it could streamline this vital piece of medical research.
It really is a potential game changer. The system they've designed is quite clever. It's essentially a 5-module AI SLR system using GPT-4. But the key thing, I think, is the human-in-the-loop design.
Okay, human in the loop. So the AI isn't just running solo. What are those 5 modules, and how does that human oversight actually, work? How does it help?
Right, so the modules cover the whole process. The literature search, setting up the protocol, then the LLM helps with abstract screening, then data extraction, and finally, summarizing the data. The human-in-the-loop part is crucial. It lets reviewers adjust criteria in real time. So they use the PICOs, framework, population, invention, comparison, outcome, study type, and if the LLM disagrees with the human reviewer on whether to include a study, the system logs that disagreement and the reason why.
Okay, so it's not just flagging errors, it's learning from them. It refines itself as it goes.
Exactly. It's an iterative learning process based on expert feedback.
That sounds powerful. But, the proof is in the pudding. How did it actually perform? Did it deliver?
It performed really well, actually. For screening abstracts, they reported an average sensitivity of 90%.
90%, so it caught almost all the relevant stuff.
Pretty much. And an F1 score of 82, which is a good balance between finding the right papers and not including too many wrong ones. Accuracy was around 89%.
Okay, that's solid for screening. What about pulling out the actual data?
Even better there, arguably. For data extraction, the F1 score hit 93. Really reliable.
Wow, 93 F1. That's high. And I saw they mentioned a Cohen's kappa of 0.71.
Yeah, 0.71, which basically means there's substantial agreement between what the AI concluded and what the human reviewers concluded. They're seeing eye to eye most of the time.
Right, which builds confidence. But here's something that really jumped out at me from the paper. It seems this system doesn't need that massive amount of pre-labeled training data that older ML models often required. Why is that such a big deal here?
Oh, that's huge, honestly. Creating those big, manually annotated data sets, that takes ages and costs a fortune. It's a major barrier. By getting rid of that need, this system becomes much more practical, much faster to deploy. Researchers, the subject matter experts, can basically guide the AI using prompts and that real-time feedback loop we talked about, instead of getting stuck labeling data for weeks or months. It puts the expert more in control.
Makes sense. So let's connect the dots. We've got impressive performance, easier implementation. What does this mean for the real world? How does it actually fix the problems with the old way of doing SLRs?
Well, the big potential here is tackling those core issues: time, cost, and human error. If you can slash those, you're not just making the process more efficient, you open the door to something called living SLRs. Think about it, reviews that aren't static snapshots from a year ago, but are continuously updated as new studies come out.
Right, almost real-time evidence synthesis.
Exactly. Imagine the impact on healthcare decisions, on policy. Clinicians and policymakers could be working with evidence that's weeks old, not months or years old. It means HTA submissions, the things that influence what treatments are available to you, can be based on the absolute latest findings.
So wrapping this part up, this LLM system with its smart human-in-the-loop design was just like a really significant step. Faster, more accurate medical research, less error-prone.
Precisely. It streamlines a fundamentally important process. So thinking bigger for a moment,
Yeah.
if AI like this can handle these complex, incredibly detailed tasks like SLRs so effectively, speeding up how we get reliable medical evidence, where else could this kind of human-in-the-loop AI make a difference? Think about other fields drowning in information that needs careful sifting. And maybe more importantly for you listening, what new questions could you start asking, knowing that the heavy lifting of gathering the foundational evidence might soon get a whole lot faster?